Now in this video we'll see the configuration of auto RP. In the previous videos we have seen the behavior of the auto RP. Now we can configure any specific router as an RP and then mapping agent. Now RP is going to advertise itself as an RP, whereas mapping agent is going to provide the RP information to the rest of the domain. Now to practically verify this, I'm going to use the same lab with 5 routers, and on all these routers and the first step I'm going to configure is IGP by using OSP of area 0, and I already did the IGP configuration just now. If you verify on the router 4, if I give show IP OSP of neighbor, I can see the neighbors, and if you verify the routing table, I have advertised all the connected interfaces as per the diagram. Now the second step is we are going to enable IPPIM sparse mode, and we want to configure the RP based on auto RP configurations. So let's go to router 1 and quickly configure the multicasting, and then interface F0 by 0 IPPIM sparse mode. On the router 1 I got S1 by 0 as well, and also I got S1 by 1. Now once we configure this, let's copy paste the same commands, because on the router 2 also I got the same interfaces, and on the router 3 also I got the same interface names, and then on the router 4 also I got the same interfaces. I got one more extra interface, S1 by 2, which is connecting to router 5, and then on the router 5 also I got IP multicast routing, and then interface F0 by 0 I'm going to configure IPPIM sparse mode, and S1 by 0 IPPIM sparse mode. I got just only 2 interfaces on the router 5. Now they should establish the neighbor relationships. So to verify that, I'm going to use show IP PIM neighbors. Now on the router 4 I can see 3 PIM neighbors. Now similar way I'll check on the router 2, show IP PIM neighbors. Show IP PIM neighbors. On the router 2 I should see 2 neighbors. And I enabled all the interfaces, so if the neighborship is not coming, just ensure that that particular interface is enabled with IPPIM sparse mode or not. Now the third step, we are going to simulate a client receiver on this interface, which is going to join the group for 224.5.5.5. Now we are going to simulate on the router 5 a client, and for that we are going to use the same commands, IP IGMP join group, and we are going to say 224.5.5.5. Now this is the way we simulate a receiver on that particular interface. Now the next thing is, if you try to generate the traffic from the router 1, you will not be able to ping to this multicast group address on the receiver, and the reason is we don't have RP. Now we need to configure the RP. We have seen some static RP configurations in our previous videos with static RP also. Now here we want to decide the RP based on the Cisco proprietary method, that is auto RP. Now the configuration wise, there are 2 specific commands we need to configure. Now we need to go to the router, whatever the router you decided to go with RP. Like in my scenario, I'm going to use the router 3 loopback 0 will be selected as a RP, and we need to configure this command IPPIM send RP announce and the loopback 0. And we need to define the scope. Scope is more like TTL value. It defines how many hops this RP information has to be propagated. And then we also need to configure the mapping agent. Now mapping agent can be the local router. The same router can be an RP as well as a mapping agent, or you can make any other router as a mapping agent also. Now to configure the mapping agent, in my scenario, I'm going to make the router 3 loopback 0 will be considered as a mapping agent also. And to configure the mapping agent, we need to say IPPIM send RP discovery messages. So send RP discovery messages is to advertise itself as a mapping agent, and whereas send RP announce is used to advertise itself as an RP. So let's go to router 3 and configure the same. Now on the router 3, I'm going to say, now before you configure this, just ensure that whatever the interface you have decided to use as an RP, that interface has to be enabled with IPPIM sparse mode, and also that interface has to be advertised inside your IGP. Now in my scenario, I'm going to advertise an IGP, because normally If you remember, we discussed that in the case of PIM register messages, it uses unicast, and that particular RP address should be reachable. Now make sure that particular interface is enabled with PIM IPPIM sparse mode. Recommended to use loopback interface, and it should be advertised inside your IGP. Now once we are done with this, then I'm going to advertise as send RP announce, and then we need to define the name of the interface. In my scenario, I'm going to use a loopback 0. You must define the scope. Scope is like TTL value, and in my scenario I don't have more than 10 routers, so I just go with 10. And the next command, we need to say send RP discovery. We are advertising itself as a mapping agent, and then we need to say loopback 0 and the scope. Now we just configure these two commands here. IPPIM send RP announce is to advertise itself as an RP, and IP send RP discovery advertise itself as a mapping agent. Now in my scenario, the router 3 is an RP as well as it is the same mapping agent as well. Now the next thing, if you go and verify from the router 1 or any router we can take. Now here I'm going to assume that the router 1 is my source from where the multicast is coming for this group. And if you try to ping from the router 1 or any specific address, I should not get the reply. So you can see here I'm trying to ping to that, but it's not getting reply. But in case of static RP, it was working, but here it's not working here. Now the reason for this is, like, if you just get back to the concepts what we discussed in the auto RP. Now auto RP is going to use two different multicast group addresses, where the candidate RP is going to advertise itself as an RP on 224.0.1.39 information, and the mapping agent is going to listen on this multicast address, and then the mapping agent is going to advertise this information to the rest of the domain on 224.0.1.40 address. Now before they actually learn about the RP, they should now the routers has to learn how to learn these address messages. Now if you just verify on the router 1, any of these routers, let's go to any one of these routers. If I go to router 1, if I give show IP mroute, now in the multicast routing table here, now these routers on the router 2, now if I check on the router 1, now the router 1 do not have information on how to reach. There is no SKG entries for these two multicast addresses used by auto RP. Now the first thing, if they want to receive that receive the multicast traffic, if they want to register with RP, they should know how to reach the RP. That's the first step. Now here in my scenario, the routers do not know how to, they don't know how to reach these multicast addresses. Now here it is like the routers cannot join to the auto RP groups without knowing the RP, because they don't know how to reach the RP, and they will not come to know about the RP without joining these groups. It's like, recursive loop where the routers has to join to these addresses in order to listen to the information of the mapping agent, but again at the same time that information is provided by RP. So to fix this kind of things, because by default if you're running a sparse mode, router cannot join to this group, that's a mapping agent. Now we need to fix this one. In order to make this possible, there are multiple possible solutions. Now we can either go with running a PIM sparse dense mode. Now in the case of sparse dense mode, it's going to work something like it's going to run the dense mode for all the groups where there is no RP configured, and it is going to use a sparse mode for all the groups wherever we have an RP. Now probably that is something you can go ahead with configuring. Instead of using just a sparse mode, you can simply go with sparse dense mode, or we can manually configure an RP. We can assign a static RP for all the routers for this two multicast addresses, so that they can listen to that multicast addresses and they can figure out the actual RP for the multicast group. Now probably that is something not recommended again, because We need to go to each and every router to define the RP for these multicast groups, and that's something not recommended. Now we can either go with sparse dense mode, or we can define a static RP for these two multicast addresses used by AutoRP, or we can simply go to each and every router and we can configure something called AutoARP listener. Now the advantage of AutoRP is it is going to use, whenever you configure on all the routers with AutoRP listener, that's the one extra configuration we need to add. Now what it is going to do is it's going to use the dense mode automatically for 239 for these two addresses, 239.0.1.40 and 39. For all the remaining groups, it's going to use sparse mode. It's going to use sparse mode for all the remaining groups. Now the major difference between the major difference between the AutoARP listener and the PIM sparse dense mode is, now in case of PIM sparse dense mode, if the RP goes away, now if the RP goes down, then it is going to fall back to the dense mode. If there is an RP, then it's going to use a sparse mode. Now if you are using AutoRP listener, then if the candidate RP goes down, so let's say the candidate RP goes down, in that case it will not fall back to the dense mode. That's the major difference between these two. Now probably in this section I'm going to configure the AutoARP listener on all the routers. So either we can go with this static RP enhancement for this group. That's something you'll find in the workbook. I have documented that as well. But right now in my lab, in order to learn about that multicast group information, I'm going to configure on all the routers. I need to say IPPIM AutoARP listener. So you can always use question mark to find allow the AutoRP packets across the sparse mode interfaces. And the same thing we need to configure on all the routers, same command on the router 2 as well, IPPIM AutoARP listener. So let me copy paste the same command on all the routers, on the router 3 and on the router 4 and then on the router 5. Now let's go and verify the same now. If I give show IPPIM RP mappings, now the router 1 should learn about the RP information. That's what I should see, because all the routers should learn about the RP information once we configure this. Now I can see router 3 is learning about the RP information here and elected via AutoRP. And let's check on the router 1 as well. Now I can see the router 1 knows about the RP information. Now once router 1 learns about the RP information, if I try to generate the traffic for 224.5.5.5, let me repeat multiple times, I should get the reply here. You can see the reply is coming from 5.5.5.2, and if you verify on the router 1, if I give show IP mroute, you can see here on the router 1, it has an information about 224.0.1.40 on the RP. And then if you verify here, the router 1 is sending the multicast traffic. You can see the S, G entries here. Let's go to router 3. On the router 3, if I give show IP mroute 224.5.5.5, I can see the entries for S, G here, where we are generating the traffic from router 1, and these are the three interfaces of the router 1 here. Now you can see here it's working fine. Now there are three possible solutions if you want the AutoRP to work. And one thing we need to, one of the major drawback with the AutoRP is they must register themselves. All the routers must listen to this multicast address. Now they should know how to reach these multicast addresses in order to listen to the AutoRP messages. Now if they don't listen, and to fix this one, either we can configure any one of these options. We can either go with PIM sparse mode, or we can configure a static RP assignment for those multicast addresses, and we can also use some AutoRP listener option as well.